Okay, so the video got a little interrupted, so here's part 2. So the question is right now, how do we know, how do we describe these sides as we were naming them? So how would you describe side BC? When I was doing this example, I was talking about the short leg and the long leg, which is easy to do because I actually knew the measurements. Not only that, but I had drawn the picture so you could kind of see a short leg and a long leg. But what if you can't, or what if you need just a better way to describe it? And we do need a better way to describe it as we get into the new functions. So in order to describe a particular side of a right triangle, number one, we're going to use hypotenuse. Hypotenuse is always going to be there when you have a right triangle. It's always the side across from your right angle, so we're going to use that. But to distinguish between these other two sides that are called the legs, we are going to actually be coming from an angle. So we're going to pick an angle. So in this side, in this particular triangle, I said I'm just going to pick angle A. Okay, it's one of the acute angles. I don't choose the right angle. The right angle is not going to be helpful. So you want to choose either A or C. I picked A. So if I choose A, then side AC is the hypotenuse. We already know that. Okay, that's a vocabulary word that should be familiar to you. But AB, I would describe AB as being next to angle A. The hypotenuse is as well, but it already has a name. So AB is the side that's next to. In math, the fancy word we use for next to is the word adjacent. So AB is what we call the adjacent side in this triangle right here. Okay? And then BC, I would say that this side is like across from angle A. Do you see how you go all the way across the triangle to get to BC? So in math, we're going to call that the opposite side. So in this triangle, we have the hypotenuse, we have the adjacent side, and we have the opposite side. All right? So let's look over here for just a second at what we were comparing before. So if we choose angle A, or angle D, or angle G, so those are all the same angle really, then BC would be the opposite side. So this is really the ratio of opposite over the 5, or the AC, that's our hypotenuse. So if I do opposite over hypotenuse in this particular triangle, or this one, that ratio is always going to be equal to 0.6. Okay, and if you think about any triangle with that same angle as angle A, so angle D is the same angle G is the same angle, we could create infinitely many triangles that have that same angle measure by just shrinking or enlarging this triangle over and over again. But that ratio of the opposite side to the hypotenuse will always be 0.6. Okay, let's look at this one. AB is the adjacent side over the hypotenuse. So this 0.8 right here, I'm running out of room on here, but I'm just going to write it right here. This is going to be the adjacent leg over the hypotenuse. These are going to be super important. And then on the last one, BC, again, is the opposite over AB, which is the adjacent. So this 0.75 is opposite over adjacent. Okay. All right, so let's just try an example really quick just with labeling the triangle. If I have this triangle and I picked this angle, the side that the right angle is pointing to, that's going to be the hypotenuse. So I'm going to label it with an H for hypotenuse. I picked this acute angle, so this side all the way across, this is going to be the opposite side. And the side that's right next to the angle that I picked, that side right there, is going to be adjacent, A for adjacent. Okay, same thing on this one. Right angle gives me hypotenuse over here. From the angle, I go to the opposite side. From the angle, I go to the adjacent side right next to it. Okay, Now we get into the actual functions. So here's where, if you have a calculator with you, or if you can open up a calculator, if you just search scientific calculator, then it will bring up a calculator for you just in Google, is fine, or wherever, because you don't have these fun little friends with you at home, or if you do, you're in big trouble because it's not yours. Anyway, on the calculator, let's see if you can see these. We have these three buttons: sine, cosine, and tangent. Okay, I know it looks like sin, cos, tan, but the real words are sine, cosine, and tangent. Now, I know that in these triangles that I drew over here, I know that these angles are all about 36.87 degrees. Now, it doesn't really matter how I know that, okay? But I know that, and so I want you to try something. If you've got your calculator, I want you to push the button that says sine, looks like sin, and then type in 36.87. And it should give you 0.6. You should see 0.6. If you don't, then it might be in what we call the wrong mode. Okay, we are using degrees. This measurement right here of 36.87, that's how big that angle is in degrees. If the calculator happens to be in radian mode, that's bad. So if you need to switch it, just look for a place where you can switch between RAD and DEG. You want degrees, okay? You should be getting, when you type this in, you should be getting 0.6. Then try this one, cosine of 36.87 should give you 0.8. It might give you 0.7999, but it will give you something really, really close to 0.8. And then on tangent of 36.87, you should be getting 0.75. Okay, now these numbers seem a little bit familiar to me because I told you we were doing some stuff over there that was like, why are we doing this? Let's see if we can find these numbers, 0.6, 0.8, and 0.75. All right. Here, the ratio of our opposite to hypotenuse in these triangles was 0.6. The ratio from the adjacent side to the hypotenuse every single time was 0.8. And the ratio from the opposite side to the adjacent side every single time was 0.75. Okay, we got those same numbers over here, which must mean that when you type sine into your calculator, it is actually calculating a ratio of side lengths in a right triangle. When you tell your calculator that one of the angles is 36.87, it knows, because you chose to ask it about sine, it knows it's a right triangle, and it's going to know that this angle is 36.87, which means it will also know the measurement of this angle. We could just subtract that from 90 and figure out what that angle measure is. Your calculator knows all of this, and therefore, no matter which of those three triangles or which of any other triangle you pick that has this angle in it, these ratios of, let's say, opposite to hypotenuse will stay constant no matter what, because the triangles are similar. So sine will always give you the ratio of opposite to hypotenuse every time. Cosine, same idea, but it's going to give you the ratio of the adjacent side to the hypotenuse every time. And then tangent is going to give you the ratio of the opposite side to the hypotenuse, again, every single time, okay? We are going to practice just writing the fractions or writing the ratios. We will get more into using your calculator next time with next lesson. So we're gonna hop over onto this other whiteboard really quick and do a couple of examples over here. So I wrote out the trig ratios, and this needs to be memorized, okay? So we're gonna come closer and show you each of these. So we've got sine, and there's this weird symbol, Okay, this symbol is a variable, just like X and Y or A and B, but this is the symbol theta. It's a Greek letter. We use Greek letters when we talk about angle measures, instead of using X and Y and A and B and all those other ones. So theta, this symbol right here, okay? So it's just kind of like saying the sine of some random angle. So the sine of any angle is equal to the ratio of opposite over hypotenuse. Cosine of any angle, or cosine of theta, equals adjacent over hypotenuse. Tangent of any angle is the ratio of the opposite side over the adjacent side. Now, I wrote this up here. Once upon a time, someone told me that Pocahontas actually had a best friend that we never learned about in the movie, and her name was Sokotoa. But really, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. It's just a memory device, actually. My favorite, though, some of my students aren't super interested in Pocahontas' best friend, but they are interested in, like, I don't know, illicit drugs, things like that. So we've got some old hippie caught another hippie tripping on acid. There's an option. Okay, no matter what, you need to memorize this. So you need to know this. Okay, and if that means that you have to write Sokotoa or some old hippie caught another hippie tripping on acid at the top of your paper every time, go for it. Okay, but you do need to have this memorized. And let me just show you really quick what it looks like when you're doing your assignment today. If I'm given this particular triangle, I will be asked to find things like this. If I'm asked to find the sine of angle theta, then I'm going to go from angle theta, and I'm going to find the opposite side, because I'm using sine, so I want the opposite side from theta, which is 5, over the hypotenuse. The hypotenuse of this triangle is 13, and that is my answer. That's all I'm looking for. What is cosine? Again, from angle theta, cosine of theta. So from angle theta, cosine asks us for adjacent over hypotenuse. This is the adjacent side, 12, over the hypotenuse, which is 13. So then tangent is opposite over adjacent, so tangent is 5 over 12. Okay, one more example. Sine, cosine, and tangent of theta. Again, from theta, we've got sine, which is opposite over hypotenuse, so 24 over 25. Cosine is, again, the ratio from adjacent to hypotenuse. So the adjacent side is the 7 over the hypotenuse, 25. Last one. Tangent, opposite over adjacent. So the opposite side is 24. The adjacent side is 7. And that is how you do your assignment. Okay? If you have any questions, please feel free to email me, and I will absolutely help you. I can make other helpful videos if you need. Your assignment is on big ideas. Intro to Trig, I think is what it's called. And make sure you get it done, and we will move on to something else on Friday. Bye.